Hello students. Today we are going to discuss about the queue in data structure. So as we discussed in my previous presentation, so we had seen what is queue and what are the different types of queue and its real life example. In today's presentation, I am going to explain about the implementation procedure of a queue. Now let us see what is queue. So queue is a data structure where elements are inserted through one end, so that end we say it as a rear end, and elements are deleted from the another end, so that is called as the front end. So it follows the FIFO procedure. Now let us see how we can implement the queue data structure. So the queue data structure can be implemented in a two different concepts, by using an array, another by using a linked list. So how by using an array? So this is what we say it as a sequential allocation. So in this implementation, so the queue can only store a limited number of elements. As we all know that in array, always before using this we have to declare it. So once we declare, the size of the array is fixed. And another type of implementing is the by linked list allocation. A queue is implemented using a linked list. It can store or it can organize an unlimited number of elements. So these are the two implementation of procedure for implementing queue data structure. Today I am going to explain about how queue is implemented using arrays. So let us see the implementation using array. So the first one as the simple queue. So simple queue is also called as ordinary queue, and it is also called as linear queue. So now what actually the linear queue is? In linear queue, an insertion takes place from one end while deletion occurs from the another end. The end at which insertion takes place is called as a rear end, and the end the deletion takes place, that when we say it as a front end. So it follows the first in first out procedure. So let us see how what are the different operations so that can be performed on simple queue or in a linear queue. The insertion, deletion, display. So these are the basic operation that can be performed on simple queue. And another method we can see peek. So peek method, it is going to return the frontmost element in the array. And another method here you can see isEmpty method. So isEmpty method, it is going to verify whether our queue is empty or not. And another method that is called as isFull method. So isFull method, it verifies whether our queue is full or not. And next another method is there that is called as a size. So it is going to find the total amount of size the queue has occupied. So these are the basic operation so that can be performed on any type of queues. Now let us see the first operation, that is insertion, how we can insert an element in a queue. So insertion is also called as enqueue operation. Now just look at the picture here, already element have been inserted. So now if I want to insert another element called 40, so what I supposed to do here is I should increment the rear pointer by 1. After incrementing the rear pointer, what I supposed to do is I should copy the particular item in the index, in the assigned index. So this is how our insertion is going to work. So here you should remember that in case our queue is empty, there are two pointers we are using. One is front pointer and the rear pointer. The front pointer and rear pointer should be initialized to -1 in case if it is empty. Okay. So in this particular case, so already 3 item has been inserted. To insert another item, so rear pointer must be incremented by 1. So this is how it has been shown in the diagram. Now let us see what are the steps that you have to remember while performing an insertion operation. The first step is you have to check whether our queue is full. Now how to check queue is full? So it will be verified based on our the size of the queue. Okay. So we have to verify whether rare is equal to q size minus 1. So this is how we have to verify it, and then in case of if our queue is not full, the next procedure itself, what we can insert an item into the particular location just by incrementing the rare pointer by 1. So this is what the procedure to increment. And next, after incrementing the rare pointer, so what we supposed to do is we have to copy the element to the queue using this particular statements, that is q of rare is equal to element. So these are the steps to perform insertion operation. Now let us see what is the C function to represent this insertion operation. So this is the C function to represent an insertion operation. So here I took my method as a insert through the rarent and its return type is void, and so here I have placed 3 different cases. The first one is I am verifying whether my queue is full by just comparing with the rarent. So if rare is equal to q size minus 1. Why it is q size minus 1? Because always in our array index starts from 0. So it should be 1 less than the array size. So rarent should be verified with the q size minus 1. So if it is equal to q size minus 1, then what we can say that q is full, or we can say that q overflow. In case if it is not equal to q size minus 1, then what we can do? So we can insert an element into the particular location just by incrementing the rare pointer by 1, that is rare is equal to rare plus 1. After incrementing the rare pointer, so next step is we have to copy the element into the particular queue. So that is q of rare is equal to element. So this is what the procedure to perform an insertion operation. Now let us see the next one, next operation, that is delete element from the queue. Now this operation is also called as dequeue operation. So by name itself indicating that deleting, in the sense already some elements are there in a queue, so we need to delete from the position. Okay. Now just look at the diagram here, you can see how element get deleted. As I already said that there are 2 pointer we are utilizing, front pointer and the rear pointer. So front pointer is indicating the beginning position and the rear pointer is indicating this one. So here to perform the deletion operation, obviously the element must be deleted through the end called front end. So as you can see here already 3 items have been placed. So the name of the items 10, 20 and 30. So already 3 elements are existing in a queue. Now if I apply the deletion operation to this queue, so what happens? The front of the element or the front item will be deleted first. So as you can see in the diagram, so what happens? The beginning index front is indicating to the 0th index. Okay. So that particular element supposed to be accessed, and then after accessing that the front pointer must be incremented by 1, okay, because here it will be moving towards the forward direction. Okay. You can just look at the diagram here how front pointer is moving towards the in a forward direction. Now let us see how to perform the deletion operation. So this is the pictorial representation of a deletion operation. So next, these are the steps that we supposed to follow. So first of all, we have to verify whether our queue is empty, and after that, so we have to return the frontmost position, and then we have to increment the front index by 1. So these are the steps to perform the deletion operation. So thank you.